In previous lecture, we has been discussed about sp hybridization. We derive the values of the coefficients a1 a2 b1 b2, and we write the corresponding equation for the two sp hybrid orbitals. Now in this lecture, I would like to continue the topic of the hybridization. Now sp2 hybridization. So it is the mixing and recasting of 1s and 2p orbitals of nearly same energy level of the same atom to produce new identical orbitals with equivalent energy and proper symmetry. This process is called as sp2 hybridization. It is the mixing and recasting of 1s and 2p orbitals of the nearly same energy of the same atom to produce the new identical orbitals with equivalent energy and proper symmetry. It is also the linear combination of 1s and 2p orbital produces three new sp2 hybrid orbitals. Three new sp2 hybrid orbitals. So there is a formation of the three sp2 hybrid orbitals here. 1s and 2p orbitals get combined. 2p orbitals get combined, mixing and recasting of 1s and 2p orbital. So which produces three sp2 hybrid orbitals, and their corresponding wave function can be written as psi sp21, then psi sp2 second, and psi sp2 third. So these sp2 hybrid orbitals are formed. Let us write now their corresponding equation. Let us write their corresponding equation. So it becomes very easy to write their corresponding equation in the sp2 hybridization. Okay, so let us write their corresponding equation. So first one, it is psi sp21, psi sp21, first hybrid orbital. It is equal to a1 psi s plus b1 psi pz. Pz, it is involved into the hybridization, and plus c1 psi py, second p orbital, that is py orbital. So this is the equation for first sp2 hybrid orbital. Then psi sp2 second hybrid orbital, the equation corresponding to this, a2 psi s plus b2 psi pz plus c2 psi py. This is the second equation. Let us give the numbering to this. This is equation 1. This is equation 2. Then third sp2 hybrid orbital. Three sp2 hybrid orbitals are formed here. So it is a3 psi s plus b3 psi pz plus c3 psi py. This is equation 3. So in this way we can write the three sp2 hybrid orbitals and their corresponding equations. So in these equations, a1, a2, a3, then b1, b2, b3, and C1, C2, C3 are the mixing coefficients of the atomic orbitals. A1 is the mixing coefficient of s orbital, A2 is the mixing coefficient of the s orbital here, B1 is the coefficient of the pz orbital, B2 is the coefficient of the pz orbital, like that. Now once we write the equation, we have to find out the corresponding values of these coefficients. Okay, so let us going to find out the corresponding values of the coefficients. So see, as s orbital is spherically symmetrical, s orbital it is spherically symmetrical, it is having the spherical shape, then the contribution of the s orbital into these three sp2 hybrid orbitals will be equal contribution is there. The contribution of the s orbital into this sp2 hybrid orbitals will be equal. Therefore we can write here, as the contribution will be equal, so the three coefficients are also same, a1 equal to a2 equal to a3. This is fourth, a1 equal to a2 equal to a3. This is known to us because s orbital it is spherically symmetrical. Now let us do the normalization of first coefficient by carrying out normalization of coefficients, first coefficient, normalizations of first coefficient of three equations, of these three equations. So let us see here, a1 a2 a3. So we can write down this a1 square plus a2 square plus a3 square, it becomes equal to 1. As we know, a1 equal to a2 equal to a3, therefore we can write this a2 equal to a1 and a3 it is also equal to a1. So this is thrice a1 square, it is equal to 1. Putting a2 equal to a1 and a3 it is also equal to a1, same. So therefore we can write here now a1 square it is equal to 1 by 3. Therefore a1 equal to 1 upon root 3. So as we get the value of the a1, but we know that a1 equal to a2 equal to a3, therefore we can write here a1 equal to a2, or a1 equal to 1 upon root 3. So it is equal to a2, it is equal to a3. So three coefficients, we find out their value, 1 upon root 3. 1 upon root 3. So this is find out by carrying out the normalization of first coefficient of the three equations. First coefficients of the three equations. Okay. Let us see now. Next. So I would like to show here. Okay, these are the three equations you can see. We have already written these three equations. A1 psi s plus B1 psi pz plus C1 psi py. Okay. Then as s orbital is spherically symmetrical, the newly formed hybrid orbitals are equivalent. S orbital can be assumed to have equal contribution in all, a1 equal to a2 equal to a3. So we are finding out the coefficients for this equation now. Psi sp1 first, psi sp2 first hybrid orbital. So carrying out normalization of the first coefficient. So according to this we can find out here a1 equal to a2 equal to a3, that is equal to 1 upon root 3. Now let the first sp2 hybrid orbital be oriented along only the z-axis. Thus only s and pz orbitals are assumed to contribute to the first sp2 hybrid orbital. Let us assume this. In the formation of first sp2 hybrid orbital, and that sp2 hybrid orbital will be oriented along the z-axis. So s orbital, it is all over the axis, x axis, y axis and z axis. Pz orbital, it is along the z axis, but py orbital, it is not there along the z axis. Okay, since py orbital does not contribute to the first sp2 hybrid orbital because it is not along the z axis, therefore its mixing coefficient, that is c1, becomes equal to 0. This c1 becomes equal to 0 here because it is not contributed here in this. We assume that s orbital and pz orbital are contributed and this py orbital is not contributed. S and pz orbital are assumed to contribute to the first sp2 hybrid orbitals. Py does not contribute. Therefore, its coefficient becomes equal to 0. Okay, so C1 becomes equal to 0. Okay. So now by carrying out the normalization of the equation 1, let us do the normalization of this equation. Okay. So you can see here how we can perform the normalization of the equation 1, taking the square of the coefficient and add them, and it becomes equal to 1. So we can write this now in this way: a1 square plus b1 square plus c1 square, it is equal to 1. Now c1 becomes equal to 0. We know the value of the a1, it is 1 upon root 3. Okay, then it is bracket square plus b1 square, c1 becomes equal to 0. So plus 0, it is equal to 1. So 1 upon root 3 square, it is 1 upon 3. So b1 square, it is equal to 1 minus 1 upon 3. Therefore, we can write here b1 square, it is equal to 2 by 3. It is equal to 2 by 3 here. Okay. So b1, it is equal to, we find out here the value of the b1, it is equal to under root of 2 upon 3. So in this way, we find out here the value of the b1, it is equal to under root of 2 upon 3. Okay. So let us see. You can see here b1, it is equal to under root of 2 upon 3 by doing this process. So we can write now the equation 1 because we know the value for the equation 1, that is already we find out. So psi sp21, it is equal to a1 psi s, a1 it is equal to 1 upon root 3 plus b1 psi pz, b1 it is equal to under root of 2 upon 3 plus c1 psi py, but c1 it is equal to 0, c1 it is equal to 0. So that third term becomes equal to 0. So we can write the equation in this way: psi sp21 becomes equal to 1 upon root 3 into psi s plus under root of 2 upon 3 into psi pz. So in this way, we derive these coefficients a1 and b1 here. C1 becomes equal to 0. Okay, by assuming the sp2 hybrid orbital is oriented along the s and pz axis, along the z axis. So py orbital is not contributed there. So coefficient of the py orbital is c1, it becomes equal to 0. Now let us see for next psi sp2 second. Let us find out the coefficients here. Psi sp2 second. First of all, write the equation here for psi sp2 second. Psi sp2 second. What is that equation? So psi sp2 second, it is equal to a2 psi s plus b2 psi pz plus c2 psi py. This is the equation. Equation 3, that is known to us. Now, carrying out the orthogonality of equation 1 and 2. Let us write here the equation 1 also. This is for psi sp21. That equation, it is equal to a1 psi s plus b1 psi pz plus c1 psi py. Okay. Now let us do the orthogonality of the equation 1 and 2. take the product of these two and add them, and it becomes equal to 0, all the coefficients here. So it is equal to a1 into a2 plus b1 into b2 plus c1 into c2, c1 into c2, and that is becomes equal to 0. Now we know a1 a2 values, it is 1 upon root 3, we find out previously. Now we find out b1 value also, b1 it is equal to this under root of 2 upon 3. We know the c1 also, c1 becomes equal to 0. So this third term becomes equal to 0 here. 0 multiplied by c2, it is 0. So according to this, by carrying out the orthogonality of the equation 1 and 2, we can find out the value of the b2 here. So let us put the values here. So a1 1 upon root 3 into a2 1 upon root 3 plus b1 under root of 2 upon 3 into b2. That value is not known to us. We have to find out that value. Now c1 is 0, so this whole term becomes equal to 0. Not necessary to write this. So therefore this is 1 by 3 goes to this side, minus 1 by 3. So it is root 2 upon 3 into b2. It is equal to minus 1 by 3. So b2 it is equal to, okay, minus 1 by 3 into root 3 upon root 2. Okay, this is goes to the numerator, root 3 by root 2. So this root 3 get cancelled here. It is root 3 here. So minus 1 upon root 3 into root 2, it is root 6. So we can write here minus 1 upon root 6. Minus 1 upon root 6. In this way, we are getting the value of the b2 here by doing the orthogonality of equation 1 and 2. See here, b2 it is equal to minus 1 upon root 6. Now carrying out the normalization of the equation 2, because we want to find out here c2, here equation to this c2 value. Okay, we find out here b2 value by doing the orthogonality of equation 1 and 2. We find out here b2 value. Now we want to find out the c2 value. So c2 value can be find out by doing normalization of this equation 2. Normalization of this equation 2, that is normalization of this equation. So you can see here normalization of this equation. This is equation 2, this is equation 1. So how we can do this? a2 square plus b2 square plus c2 square, it is becomes equal to 1. Okay, so you can see here a2, that value is known to us 1 upon root 3. So 1 upon root 3 square. b2 square, we find out the b2 value here, minus 1 upon root 6 plus in bracket minus 1 upon root 6 square. That is the value of the b2. Okay, plus c2 square. So c2 we have to find out, it is equal to 1. So this is 1 by 3. This is plus 1 by 6 plus c2 equal to 1. So let us do this. So c2 it is equal to 1 minus 1 by 3 minus 1 by 6. So it can be simplified, 6 it is LCM. So we can find out this 6 minus 2 minus 1 divided by 6. So it is 3 divided by 6. It is 1 by 2. So in this way we can find out here c2 square, it is equal to 1 by 2. Therefore c2 it is equal to 1 upon root 2. So we are getting here the value of the c2. Let us check this. c2 becomes equal to 1 upon root 2. Okay, c2 becomes equal to 1 upon root 2 here. So therefore we can write now that equation 2 psi sp2 equation 2 becomes equal to 1 upon root 3, that is a2 into psi s. b2 it is minus 1 upon root 6, so minus 1 upon root 6 into psi pz. And c2 now just we find out the value of the c2, 1 upon root 2 psi py. So in this way we can write this equation 2 here by find out their coefficient values. Now the remaining is the last psi sp2 third. Okay, by carrying out the orthogonality of equation 1 and 3, orthogonality of the equation 1 and 3, let us write here once again the equation 1 and 3. Okay, so equation 1 it is psi sp2 square 1, it is equal to a1 psi s plus b1 psi pz plus c1 psi py. This is equation 1. Now 3 psi sp2 3, because we want to find out the coefficient of this equation. This is equation 3. So this is a3 psi s plus b3 psi pz plus c3 psi py. Okay, this is equation 3. So we have to carry the orthogonality of equation 1 and 3, means we have to take the product of the coefficient. This is a1 a3. So we can write here a1 into a3 plus b1 into b3 plus c1 into c3. It is equal to 0. You can see here. Now we know a1 a3 value, b1 is also known to us. We know c1 value, c1 becomes equal to 0. Okay, c1 becomes equal to 0. So we can write this now by putting this a1 1 upon root 3 into 1 upon root 3. a3 is both are having the same values plus b1. b1 should be equal to under root of 2 by 3 into b3. b3 we want to find out plus c1. c1 becomes equal to 0 into c3. It is equal to 0. So this is 1 by 3 plus 2 upon 3 into b3. It is equal to 0. So therefore b3 it is equal to b3 it is equal to, so let us see, minus 1 by 3 here on this side, it goes to right side minus 1 by 3 into this goes to the numerator root 3 divided by root 2. So once again this is root 3. So b3 is also equal to minus 1 upon root 6. You can check this, b3 is equal to minus 1 upon root 6. So in this way, by carrying out the orthogonality of equation 1 and 3, we find out here the b3. What is remaining now? c3 here. So we find out here the b3. Now by carrying out the orthogonality of equation 2 and 3 or 3 and 2. Okay, because in this case we have to find out the value of the c3 here. Okay, we know the value of the b3, it is equal to minus 1 upon root 6. We know the value of the b1 under root of 2 by 3, but we are not knowing the value of this. Okay, so let us go into this. Carrying out orthogonality of equation 3 and 2. Okay, carrying out orthogonality of equation 3 and 2. So let us write down both the equations once again here. Okay, let us write down both the equations here. So see here, equation 3 and 2. First of all, write the equation 2 here. Psi sp2 second, it is equal to a2 psi s plus b2 psi pz plus c2 psi py. This is equation 2. Psi sp2 third. So it is A3 psi s plus B3 psi pz plus C3 psi py. So what is given here? By carrying out the orthogonality of equation 2 and 3, this 2 and 3. So we can write here A2 A3 taking the product plus B2 B3 plus C2 C3. C2 C3 becomes equal to 0. We know A2 A3. Okay, these two values are known to us. We know B2 B3. You can see B2 B3. B3 it is equal to 1 up, minus 1 upon root 6. Then we know B2 value here. Okay, B2 value is also known to us. B3 becomes equal to minus 1 upon root 6. Okay, then B2 value, let us say where is the B2 value here. B2 becomes equal to minus 1 upon root 6. Okay, so that values are known to us. B2 B3 is also known to us. Okay, then C2 C3. What is the value of the C2? Let us check this C2 value. C2 value where C2 equal to 1 upon root 2. So just we have to put that values here. Okay, so let us do this. Put the values here into this equation. So you can see here A2 A3 plus B2 B3 plus C2 C3 becomes equal to 0. A2 A3 both are having the same values 1 upon root 3 square. B2 B3 they are also having the same value minus 1 upon root 6 square. B2 equal to minus 1 upon root 6. B3 is also equal to minus 1 upon root 6. Then C2 it is known to us 1 upon root 2 into C3. So according to this we can find out the value of the C3. So by simplifying here we will get the value of the C3 becomes equal to minus 1 upon root 2. So then we can write here C3 it is equal to C3 it is equal to minus 1 upon root 2. C3 it is equal to minus 1 upon root 2 here by doing the orthogonality of the equation 2 and 3. So thus all the coefficients are known to us. Then we can write the third equation here. Psi sp2 third. A3 psi s. A3 equal to 1 upon root 3 plus B3 psi pz. B3 should be equal to minus 1 upon root 6. Then plus C3 psi py. C3 just we have find out minus 1 upon root 2. So in this way we can write the third equations here by doing the orthogonality of equation 2 and 3. So in this way by performing the normalization of the equation and orthogonality of the equation. When we are doing the orthogonality we require the two equations, and when we are doing the normalization we just require the coefficients of the two equations or three equations, or one equation is also okay, just we have to take the square of the coefficients. So in this way we can find out this equation now here. Okay, so this is for psi sp2 third hybrid orbitals. Now let us take the example here. After finding out their corresponding equations, let us take the example of this type of the hybridization, sp2 hybridization. It is boron trifluoride molecule, BF3 molecule. Boron is the central atom. Let us write the electronic configuration of the boron 5 1s2 2s2 2p z1 2py0 2px0. Okay, so 2pz is having the one electron. Ground state 2s2 2pz1. Promotion of this electron here because 3 fluorine atoms going to form the bond with the boron. So we require 3 unpaired electrons, 3 half-filled orbitals. We require 3 half-filled orbitals. Okay, 3 half-filled orbitals here. So by promoting that electron, now you can see three half-filled orbitals are there. 2s orbital, 2pz and 2py1. 2py. Each orbital is unpaired having the unpaired electron, it is half filled orbital. So mixing and recasting of these two, 1s and 2p orbital. So hybridization is here, sp2 hybridization. This sp2 hybridization. There is a formation of the 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. So in this way, in the boron trifluoride molecule, the central fluorine atom, central boron atom undergoes sp2 hybridization. Diagrammatically, we can show the sp2 hybridization in this way. S orbital spherical shape, sp2, only two p orbitals are there. So this is pz orbital and this is py orbital, where these orbitals are perpendicular to each other. After the mixing, that is such type of the shape is there, psi sp2 third hybrid orbital. This is psi sp2 one, this is psi sp2 second. So this is the shape of the sp2 hybrid orbital. It is okay. Now the peripheral atom, it is fluorine atom with atomic number 9, and it is having the electronic configuration. Now only one orbital is there, 2pz, having the one unpaired electron, or this is up-filled orbital. So it can be overlap with, show here. This is the orbital of the fluorine. Okay, can be overlap with this. 3 fluorine atoms having such orbital. So we can show the bonding in this way. Sigma bond, sigma bond, sigma bond formed by the overlapping of the atomic orbitals. So this diagram shows that it is having the planar geometry, triangular planar. It is triangular planar. Bond angle, it is 120 degree. So in this way we explain sp2 hybridization. sp2 hybridization. There is a formation of the 3 sp2 hybrid orbitals. sp2 1, sp2 second, sp2 3. Okay. So in this way, we explain the sp2 hybridization, their corresponding equation and corresponding diagram also. Their corresponding diagrams.